In this lesson, we're going to talk about types of chemical bonding, this time covalent. Now we know covalent bonds are the sharing of electrons between non-metals. So last lesson we talked about ionic bonds, this time we're talking about covalent bonds. So what are covalent bonds? It's formed between two non-metals sharing electrons. So there's no transfer electrons this time. And because of that, they form what we call covalent compounds. Sometimes they're called molecular compounds. Now, even though they share electrons, they still must follow the octet rule. So this is an example of a covalent bond. Two hydrogen atoms coming together, sharing electrons by overlapping their bonds. Same thing with fluorine. They're going to share, and thus they have a full octet. So hydrogen only needs 2 electrons in its outermost shell. It has a full octet. Fluorine only needs 2 electrons in its outermost shell. It has a full octet. So how do we classify covalent bonds? Well, there's actually a way to split off how we classify covalent bonds. Alright. So there's 2 types. Okay. The first type is called polar. Polar is where there's an unequal sharing of electrons. Then the second type must be nonpolar, which is a equal sharing electrons. Now what will cause this unequal or equal share electrons? The electronegativity. It's due to En. For example, if you have fluorine with oxygen, fluorine wants electrons, and because of that, it's going to want more electrons, so it's got to pull electrons towards it. So, what happens because of this? So, the high En element will pull the electrons closer to it. And this will form what we call a dipole. A dipole just means an unequal sharing of electrons. So look at this example right here. We know ionic bonds means a full transfer of electrons. We see here a nonpolar covalent means that you're going to have an equal sharing. So this is equal. But if you notice, polar covalent is unequal. And these symbols right there are, in this case, this is delta positive. Because it's unequal, it has a slight positive charge. And thus, because this has more electrons around it, it's slightly negative charge. So what are some properties of covalent bonds? Well, the first thing we gotta know is covalent bonds are strong. And if they are crystals, for example, they will have high melting point, like diamond. But if they're not crystals, like oxygen gas, they will have low melting points. Remember, melting points are, in this case, it's breaking bonds. And we're going to talk about what bonds are breaking in this case. So how do you write the chemical formula of covalent compounds? Well, it's similar to ionic, but it now depends on the valence of the atom. And you use this valence atom as, in a sense, its charge. So what does that look like? Well, you still, in a sense, find the LCM. Now, what is valence of the atom again? Well, valence of the atom is how many unpaired electrons an atom has. Usually this is related to its charge, but because there's no charge involved in covalent, we call it the valence of the atom. So let's take a look. If you drew the Bohr models of each of these, you would see that boron would look like this, the Lewis structure of it. And carbon will look like this. So because of these, you guys see that boron has a valence of the atom of 3, and carbon has a valence of the atom of 4. So in a sense, you can think of them as having those charges, where boron has a charge of 3, carbon has a charge of 4, and you still have to find the LCM of them. The LCM of them is 12. So what's that going to lead to? You're going to have, in this case, 4 borons for every 3 carbons to form these covalent compounds. Let's take a look at the next one. Nitrogen and oxygen. Nitrogen has a valence of, if you drew the Lewis structure of nitrogen, you're going to see nitrogen has a valence of the atom, unpaired electrons. They're not paired because these are paired. These yellow ones I'm going to highlight are unpaired. So nitrogen has a valence of the atom of 3. Oxygen has a valence of atom of, in this case, 2. So what's going to happen? You have nitrogen and you have oxygen. The LCM this time is going to be 6. So you're going to form, in this case, 2 nitrogens and 3 oxygens. So you form dinitrogen trioxide. Now I know nitrogen and oxygen will form other types of compounds, and that is due to other reasons involving its double bonds and triple bonds, but that will come into play later on. Let's look at carbon and oxygen last. Carbon and oxygen, well, carbon again has valence of the atom of 4. That means it wants to bond 4 electrons. Oxygen has, again, 2. So what's going to happen is carbon is going to have a valence atom of 4. Oxygen has a valence atom of 2. The LCM this time is 2. So 4, I mean, not 2, 4. And thus, you're going to get 1 carbon and 2 oxygens, and that's carbon dioxide. Then, how do we know if an element will form an ionic bond or a covalent bond? Well, we look at the difference in electronegativity. So you remember in the last lesson, we looked at this graph, or this periodic table, we saw the numbers of electronegativity, and we saw a chart at the bottom that says if the difference in electronegativity is 4 to 1.7, if you subtract the 2 electronegativity, they'll be ionic. Between 1.7 and 0.4, it'll be polar covalent, and less than 0.4, it's non-polar covalent. Now these numbers aren't exact. If they fall on that region, you'll have a blend, because most bonds are usually a blend of all these types of bonds. So, how do we find if it's going to form what type of bond? It's the difference of electronegativity. That means if it's between 1.7 to 4.0, it will be an ionic bond. If it's between 0.4 to 1.7, it will be a polar covalent. And if it's between 0 to 0.4, it will be a non-polar covalent bond. Okay, so what does it look like? Well, if you look at this example here, sodium and chlorine. So the electronegativity table is on a previous page. What you can do is you can print this out. I'll just flip to it up to the top. You see sodium is 0.9, chlorine is 3.0. So what that's going to mean is you're going to have a 3.0. So let's write this out first. Sodium, Sodium is 0.9, chlorine is 3.0. 3.0 take away 0.9 is equal to 2.1. This is an ionic bond. Okay, fluorine and fluorine. Well, if I look at fluorines, I see it's 4.0. There's 2 fluorines. What does that mean? If there's 2 fluorines, it means that you're going to have a 4 minus a 4. What's 4 take away 4? 4 take away 4 is, trick question, 0. And that means you're going to form a non-polar covalent, which makes sense because they're going to be equal sharing of electrons. The last one's carbon and oxygen. Carbon has a electronegativity of 3. Oxygen has electronegativity of 3.5. Well, what's going to form this time? 3.5 take away 3.0. In this case, wait, let me check one more second, making sure it is 3.0. Actually, carbon is actually 2.5, not 3.0. Nitrogen is 3.0. So this is actually 2.5. So carbon is 2.5. 3.5 take away 2.5, that is 1.0. And using this chart, that means carbon and oxygen will form what we call polar covalent compound. So the homework is right there. Make sure you keep yourself safe and healthy, and I'll see you soon.